Hi, good morning, everyone.
Good morning.
Good morning, Mornin.
Hey, hi. Will you be walking? I think. Fine. Okay. Yes. As Murray mentioned, my name is also Morning. I'm good morning. Good morning. Yes. Thank you. Thank you for the warm welcome. Okay. Is it? Apologies. Okay. Cool. Okay. No. Yeah. So, quick introduction about myself. I'm a faculty in National University of Singapore.
Your mic doesn't work.
Okay.
Talk loud, but your mic doesn't work.
Hello. Yeah, oh, wow, it works. Okay, cool. Yes, oh, quite loud. Okay, once again, yeah, I just flew in from Singapore. I'm the Assistant Director of Research, Black Cat Healthcare in the Institute of Data Science, Singapore. I'm also the Singapore OHDSI chapter. First, great thanks to OHDSI to welcome Singapore to this huge family. And also, I'd like to use this opportunity to introduce my colleagues, Mukesh and Cindy from Singapore as well. Woohoo! Please be nice to them. There's only 3 of us here, so in a small group. And then, of course, joining me, we have a veteran, very experienced researcher in OHDSI, Mornin. What that means is any easy questions, I will take it. Any tough ones, I will okay? I will prepare you first. Right? Okay, so my portion, I'll quickly introduce the fundamentals of OHDSI common data model and the vocabulary. And then I'll pass to our very handsome and charming colleague Alex to talk about the more important stuff of the ETL. Okay, again, in case you haven't recognized us, it's 2 of us. And obviously I shrink myself to make my face a little bit smaller. But we did that. Okay, quickly, why do we need common data model to begin with? Okay, please allow me to quote an example that actually created by Claire, who's the leader for OHDSI common data model. Claire can't join us today, so I kind of stole a borrowed example. Okay, what happened is actually an example in the States. In the late 90s, when there are railways and trains, in the beginning, railways were built to bring workers and cargoes from rural areas to the towns. So there are many companies, many owners build their own railways. It was fine in the beginning. However, when the railway system started to grow and they start to join each other, then turns out to some issue happen, because all these companies initially they built all their own railways, their own size, their own width of the railways in their own standards, right? Because they never talk to each other. But now since the 2 railways are joining to one another, then there's this famous problem called the break-off gauge. What it means is that when 2 companies' railway joined, and the railways actually had different sizes, you will see this massive scene there. What happened? What they have to do is actually they have to stop at the junction. They have to ask all the passengers to get off the cart and on board to another train, and also they unload all the cargoes and everything on the train, because the railways are not in the same size and they cannot interconnect. Right? So that's the railway example of when you lack of a standard, what can't happen, or what's very unsustainable and non-scalable. And let me give you a real example in healthcare, in particular the usage of electronic medical record data for healthcare or clinical research happening in Singapore. And actually that leads to the beginning of Singapore's journey to reap OHDSI and OMOP CDM, and eventually lead us to be one of the chapter in OHDSI as well. So in case you are not familiar with the Singapore healthcare system, 90% of our healthcare service is provided by our public resources, managed by our Ministry of Health. Now, Ministry of Health, brilliantly, for some reason, we are a very small island, 6 million population, tiny island. From this is the east, that's the west, on the highway, one way to the other, 40 minutes only. Yet, our Ministry of Health, I hope this is not recording, decided to cut the island into 3 pieces. Right? National University and our National University Health System take care of the west part of the island, with about 2 million populations, with 3 hospitals and many clinics take care of their population. In the middle, we have National Health Group that take care of it, and and also a couple of hospitals and clinics, and they are working with the Nanyang Technology University and the medical school. Right, so I'm not sure, again, the relationship between National University of Singapore and NTU, the Singapore is like MIT and Harvard, okay, we love and hate each other. So we have two medical schools managing two clusters, and on the west, we have the SingHealth, another healthcare cluster, managed by another medical school called the Duke NUS Medical School. Okay, you may start to see things happening. And then, good news is that at about 2018, we have two very enthusiastic principal investigators working on type 2 diabetes from two hospitals in Singapore, put in effort to collect two sizable cohorts in the Singapore sense about type 2 diabetes patients. Right? One from the Khoo Park Hospital that have 5,000 patients from type 2 diabetes, and the other one with 10,000 type 2 diabetes patients from National University Hospital. And the thing is, Khoo Park Hospital belongs to the middle green part, and National University Health System belongs to the blue, the west part that works with us. As I mentioned, it's managed by two different healthcare clusters, two different kind of corporates, and two different medical schools. Right? They run different electronic medical record systems. They do some common vocabularies like SNOMED and ICD-10. However, they have their own vocabulary as well. There are different teams of data scientists, etc. So I hope you already see the smell, the troubles coming, right? With these two guys try to work together, although we have a nice cohort, both sides committed both fundings and manpower to create this cohort and collect all the data. However, to conduct any research on it it wasn't possible at that point of time. So we've been looking around for a solution that how do we manage to integrate and standardize this data. And to be honest, we have been exploring multiple options, not just OMOP CDM, right, including I2, B2, and some others. And after actually about 1 year of investigation and exploration, we finally realized or believe that OHDSI or OMOP Common Data Model will be the solution for our trouble. Yeah, go OHDSI. Yes, yes. And exactly as I mentioned, that marks the beginning of Singapore's journey with OMOP OHDSI. What happens is that, okay, I take the credit. I managed to convince both PI or both institutes to invest manpower to convert all their cohort data to the OMOP Common Data Model. And same as the real example, now you can see that the both hospitals, although have their different back-end electronic medical record system, that like the railways have different sizes. But after they map into the OMOP Common Data Model, now they have a railway that on the same size, that the data from both ends can kind of being flow from one another, and the models can be built on top of both institutes seamlessly, and analysis can be done on both institutes seamlessly. So yeah, that's the story of Singapore, and Singapore is actually one of the new members in the community, and especially just now mentioned, for those who would like to have more publication under your name, OMOP CDM has been proven to be a very successful model to cultivate cross-institute, cross-country, large-scale, multi-center studies, right? So the initial ETL process, the mapping process was not easy. It wasn't trivial. It takes time, takes manpower. However, once you go through all those hurdles and standardize your data and join this community under OMOP CDM, the fruits come is that you can see the number of papers the OHDSI community published every year. 2020, because this data hasn't finished by the end of the year, so it's slightly lower. And a closer example for APAC, right? So last year, our APAC OHDSI community joining yes. Right, and many of the auditors are in the room as well, so do talk to them, right? And I'm one of them too. I'm glad to be very honored to be one of the committee, and I hope you see that what doors or the opportunities, right? You will have once you, as I mentioned, you manage to finish and go through the initial process of standardizing and mapping your data to the OMOP CDM. Okay, I believe I've pitched enough, and hopefully I have triggered your interest enough to understand more about what exactly OMOP CDM is. Okay, I think it's quite a formal definition of what OMOP CDM is. It is a system of tables, vocabularies, and conventions that allow observational healthcare data to be standardized. Right? That's the keyword we're talking about. It is the standard approach that facilitates rapid innovations in the area of open source development, method research, and evidence generation. Another keyword to mark is open source. Right? The beautiful thing about open source community is that all the researchers in the communities are very proactive and eager to share their knowledge and prior experience with the rest of the world. Right? For example, people have conducted studies with I use diabetes. They will share their cohort definition of type 2 diabetes. Well, so the others don't have to start from scratch, right? And last year we have an entire February month of sharing every single day, sharing a phenotype definition of a different disease or different conditions, right? So researchers from around the world are contributing to this pool of knowledge, so that newcomers will never have to start from scratch, and everyone is exchanging our knowledge and experience underneath this open source environment. And as I mentioned in the definition, OMOP CDN is a combination of tables, vocabularies, and convention. And here are all the tables, as Patrick just now shared, under the OMOP CDN. I will zoom into those one by one, no worries. Okay, let's first go to the vocabularies tables, right? Standard vocabulary tables. Okay, so what OMOP vocabulary means is basically a huge dictionaries of all the concepts, be it clinical concepts, operational concepts you can see in an observational healthcare study, right? It currently includes more than 8 billion of concepts, and is constantly growing as we are getting more and more data and expanding our dictionary to more domains, like we're including more events or omics study concepts into these dictionaries as well. So a little bit technical here. Before I go into the dictionary, I want to show you how this dictionary is actually organized, so help you to understand. So in the database, for those familiar with database, how many of you familiar with relational database? Wow, cool. Okay. So how many of you heard of the star schema? Wow, cool. Yes, some of you. Okay. So this is actually a famous star schema in a relational database. Okay. It does look like a star. What it means is that in the middle of star is the most core table called a concept table. And this table includes all the 8 million plus concepts. But every single concept like I mentioned is a concept that may be used in any observational study. It's in the middle table. Okay? Around the middle table, we have other tables that add in more information about the concepts. For example, we have the so the mouse is moving? Yes. Okay. Yeah, we have the domain table that tells you this concept belongs to which domain. We categorize our concepts in mainly 6 domains: drugs, conditions, measurements, device. Sorry, I forgot the next. Okay, but next nice comes up. Let me see. Pick a little bit. Observations and precision. Yes, and besides domain, we have classes, and we'll tell you which class the concept belongs to. And here down here we have a very important table called the source to concept mapping table. Because I mentioned this vocabulary is a OMOP vocabulary dictionary, right? Obviously, it has many overlaps with the current standard, clinical standard out there, like SNOMED, ICD-9, ICD-10, RX-0. This mapping table actually records the mapping between all these standardized source to the OMOP dictionary, right? So in your EHR, depends on which vocabulary you are using, it allows you to map from your EHR to the OMOP vocabulary. Another very important, interesting table is it tells you the ancestor information about the concept. So following the hierarchical structure like SNOMED and ICD-9, the OMOP dictionary have a hierarchical structures as well. So for every single concept, you will know who's the ancestors and who's the children, etc. And that was the back end. And the front end, actually the OHDSI team have built a very beautiful front end called the Adina, where it's like a online lookup dictionary for you to look through all these 8 million concepts. Okay, now let me see whether I can do a live demo here, which is always proven to be very tricky. Okay, as you can see, we have 6 main domains, right? For all these, you can click on any domain to cast a search live online. For example, we have been talking about type 2 diabetes. So you can click the search button. All the concept related to type 2 diabetes pops up, and the first one is the standard type 2 diabetes concept. If you click it, okay, to me what's more useful is, of course, defines type 2 diabetes. What's more useful is that it shows you the mapping, as I mentioned, to the source vocabulary. Here, the first batch of source IDs is SNOMED IDs. It tells you that this concept in OMOP, type 2 diabetes, with a certain code, it maps to a bunch of SNOMED IDs, not just one, a long list of them, all part under this concept. And not just SNOMED, if you go down further, we have mapping from ICD-9 and ICD-10 to this concept as well. So why I like this is previously I may have written some SQL code and study codes based on either ICD-9 or SNOMED. Now I can translate that study easily using OMOP vocabulary based on this mapping. Okay. And the dictionary is so huge that Patrick is the expert, that Patrick can tell you all these funny little conditions that one can find, and then Patrick create interesting games, right? Not sure, Patrick, on top of your head, what's the most exotic and interesting concept you've ever seen in a film?
Most interesting concept in the vocabulary? Give me 5 minutes, I'll find a good one relevant to this.
Okay, go after Patrick. Yep. Okay, so yeah, so I help you to see like touch and feel, right? Like all these things we talk about are real, happening, and you can explore it, browse through it. And I will share the link at the end of the presentation so you have a copy. Okay, so I've been talking about mapping, right? Mapping your hospital's concept or your hospital's vocabulary to our OMOP vocabulary. You was thinking like, that's a huge job, right? You guys have 8 million concepts, right? My hospital use so many different codes as well, like some of the codes are probably not even standardized. No worries, as I mentioned, it's an open source community, right? So a lot of things our veteran experienced researchers have already developed, and many tools are available under OHDSI, allow you to use. And for vocabulary mapping, one of the very handy tools is called OHDSI. The link here, and here's the wiki page, right? So OHDSI is a software tool that helps you to automatically map, I would say 90% to 95% of the concept to OMOP vocabulary. The remaining 5%, based on my experience, inevitably you have to put in some manpower and manual effort to slowly go through them and verify them. Okay, so with OHDSI, the mapping process actually is quite straightforward, right? So you just need to load all the codes from the source system, we call it the source codes, be it SNOMED, ICD-9, or whatsoever, and then OHDSI will map your source codes to the OMOP vocabulary based on tongue similarity matching, right? So they have intelligent building to help you finish, as I say, majority proportion of the mapping. And on top of that, they provide an interface allow you to verify these mappings, change some of these mappings, or even create new mappings based on the local application and local site situations. And after that, after you finalize all the mappings, as I mentioned, then you store this mapping in this source or concept map, so that later on you know how you map from hospital data to our OMOP vocabulary. Okay, and the beauty of the mapping your concept into OMO vocabulary is that you can use OMO vocabulary as a middleman, right? An exchange to exchange codes between other standards like ICD 9 to SNOMED, ICD 10 to SNOMED, NDC to IXNOM, and etc. So OMO vocabulary conveniently becomes a common standard, allows you to do more of this mapping. Okay, that was all about vocabulary, which, like I mentioned, forms the foundation of the entire CDM. And then, on the left-hand side, we have about 20 tables here, which are also important, are the clinical data tables. Okay, and with all this vocabulary being coded, now all these clinical observational tables are the tables basically all designed with the patient as a centric, right? So describe what happened to the patients during their visit to the hospitals and what we call encounter as well. So as I mentioned, the patient is right in the middle. We have a table called a person table that describes the patient's ID, the patient's, of course we remove names, etc. Patient's birthday, ethnicity, gender, and the basic demographics. That around these patients, we have a table called death that records the mortality information of the patient, which is very important because mortality are commonly used as our primary outcomes. We have an observational period table that records the duration that for that particular encounter or visit to the hospital, how long the patient stayed. We have the visit table that records the encounter information. We have condition that records the diagnosis of the patient for that particular encounter, drugs for medication, procedure, table for devices, measurements, specimen for lab tests, all sorts of notes, etc. So yeah, you can see that we have all these tables surrounding the patient, describing everything we can correct or observe and measure, all the medication intervention that procedure we're giving to this particular patient. Right, and that's the clinical portion. And then beyond that, we have data about the service provider, the healthcare provider as well, that records where they are, where the patient was admitted to, which ward, who is the provider, of course, the provider ID, not the actual name, for their privacy, and also the green portion of these tables that records the costing, the economies behind that visit as well. So at this point, I would like to show you some other very useful information online as well. So here is the wiki page for OMOP CDM version 5.4. Version 5.4 is currently the latest. It's the latest version for OMOP CDM. Okay, all these links I'm sharing on the slide, so you don't have to copy down now. This is very useful page. All the table I mentioned to you, I went through them very quickly, but actually you can click through here. It lists out all the tables here. It tells you what information these tables records, right? It tells you the conventions. More importantly, it tells you every single field what is recorded under this table, right? So take the person table, which is the center table, as I mentioned as an example. Your patient ID that uniquely define who this patient is. We have gender concept ID. I hope now you're able to conceptualize. It's a concept ID that you look into the vocabulary, then you know what gender profile of the patient identified as, the year of birth, month, day, time of birth, etc. And of course the race and ethnicity, identity, and other demographic information as well. Okay, and the visit detail tables that documents a lot of the details about that particular encounter the patient into. We have a unique ID to define that visit itself. We have a secondary ID with the patient ID to tell you, or the person ID to tell you which patient that we are talking about here. And then, of course, we'll document the start time, end time, or their durations, and why the patients are here, etc. We have drugs exposure table that document all the medication the patient under and the conditions that we were talking about. That tells you that what condition the patient was diagnosed with or had made a call for that particular visit, right? So, as I mentioned, that information is important. If you have the information, the table actually allows you not just to record when the patient may have died, but to many studies, it can be important the cause of death as well, right? So I'm not going to go through every single table here in the interest of time, but I'd like to share with you these are the useful information you can easily find under the OHDSI websites and under our wiki page. Okay, so and the links to both Athena, which is the vocabulary I showed you early on, and also the common data model is shared right here. And I think quite nicely, I leave about 5 minutes before the tea break. I think it's a perfect time that you have any tough question that you can now engage more in. I'm done part. Okay, thank you. I hope you now get a rough understanding of what CDM and vocabulary is. Thank you. Pardon me?
You're not letting him ask questions.
Yes, please. Yes, questions for me.
Questions? Anybody got questions?
Yeah, questions, anything. Yeah. About the vocabulary, the common data model.
What about CDM 6?
Good question.
Sorry.
What about 5.4?
Yeah, we're now at 5.4, yeah. Okay, there was, okay, I believe later in the afternoon, the other speakers are going to share more. I haven't shown a lot of other useful resources here in the interest of time and everything. There's another thing is there's a forum under OHDSI where I like to hang around all the time. In the forum, you can all find this information from the OHDSI website. In the forum, there are people posting call for participation of studies. So people that will post and call for sites to join their studies. So you can go there, find information, and join the study that you are interested in. And also there are technical forums that people share their experience, etc. And in addition to the forum, there's actually a GitHub, like I mentioned, is an open source platform that all the source codes are shared under GitHub. Okay? So yes, I can see my co-instructors, Alex and Maria here. Yes.
So the answer. Okay, so the answer, Mark's question, where's CDM 6? Right? It's actually a good question. We have a working group called the OHDSI CDM Working Group, and their job is to update the CDM based on needs from different individual and different stakeholders. Okay, and we are working on it. 6 did come out, and then we took it back, and we made it 5.4 because 6 has a bit more of a bigger structural change than what the community was able to adapt at that point in time. So we're trying to figure out how to properly release a newer version of the CDM that changes the model a bit without impacting everybody, right? Because that's one of the things we want to make sure the community is able to do with the updates to make sure things are interoperable with your oldest version and this newest version, and making the adoption of any change easier. So there's your answer to why 6 and where it is. So maybe next year. Oh no, we have another question. Dang, yes.
Is 5.4?
Hold. I'm gonna go over. Come over here and give you the mic so it's recorded. Oh, your microphone has. Hey, that's what happens when you ask a question. Ooh, it works. There you go.
Oh.
Yep.
Is it working?
Yes, say who you are.
Oh, I need to do that? Okay. I like to be anonymous, but yeah. Hi, my name is Song. I'm from IQVIA. I work with Mui on the OHDSI APAC coordination. So my question is OMOP 5.4 compatible with the Odyssey tools like Atlas? Completely, 100%.
So you see a lot of nods over there, yes.
Okay.
And that's one of the reasons, some of the reasons why we took 6 back, right? Because it wasn't just about people, but also the tools. We needed to make sure all of the ecosystem that Odyssey collaborators use is able to support the CDM version that we're going out with. So yes, 5.4 is supported by all of the Odyssey tools.
So 6.0 is still on the website, right, though? Or is it being taken off completely at this moment? Last time I checked, it was there.
It's there,
Okay.
it's there. But again, we're not it's not officially released.
Yeah, we're not promoting the update.
Correct, we're not promoting it because it does a big structural change to the model and many of the tools, like what the other faculty staff will talk about later today, doesn't support it yet.
Yeah, I'm asking because a lot of people like the latest stuff, and they keep asking why don't you do 6.0 like Mark questioned, right? So I think it is a good question. Then another question related would be.
Anyone else has another question
Oh,
before?
sorry.
So keep asking questions.
Yes, the gentleman.
Yeah, please. Yeah,
Yes,
sorry.
go ahead.
So I'm Khoi, a PhD student in TMU. So I have one question about the vocabulary, because you have some kinds of keywords from the other database. For example, PubMed, they have a match term. The keywords in Embase will be in the M3s. And so how you can collect the two into your keywords or database? Because it's slightly different. It's not the big vocabulary is normal, but some kinds of small keywords in match term is different from entries. And now you have your own vocabularies in ODC. So how you can manage about that?
You want to take that, Patrick?
Yeah, so Patrick nodding his head very
So first of all, my favorite concept is 4151745.
417.
4151
4151.
745. 745.
745. 45. There you
That's the
go.
one?
Good. 是什么呢?
Must be something.
And while that's loading, to your question, specifically mesh is a vocabulary that we actually have mapped into the vocabulary. So you can actually use a mesh term and follow the mapping actually to the SNOMED vocabulary. And that actually can be quite helpful, particularly if you're trying to navigate from publications to data.
Fourth down.
Right? Why didn't it show up? 4151. Born in Taiwan. Somebody found it.
4-1. Yeah, maybe remove your mask, Patrick, for that.
4151745.
Yeah, it is.
4151745. 415.
Interesting.
Patrick. Oh, that's because you have a filter on. Don't ever filter. No, you guys can't see it. I can. He filtered by Mornin.
And it's a standard concept.
Yeah, it's a standard one. It's an observation. Okay. It's an observation.
So yeah, Morning, that is much better than 41522239.
4152.
239. So it's an important question. If you are familiar with different vocabularies, you may find a need to go from that vocabulary into our standards. And we have mappings for many different vocabularies that are available. And if we don't have mappings, then there's an opportunity to create a mapping. Specifically for mesh, we can think of mesh usually as a very good classification system because it's kind of a grouping of a lot of different terms, and that can be helpful to navigate the vocabulary. Or as you are describing, if you just want to use it as terms, to look up, then much like Mornin's showing here, you could search for a word in mesh and then navigate to the concept in SNOMED or whatever other vocabulary. And we do that quite a lot.
Does this work? No. Any other question? No. All right. With that, we're going to go to a 10-minute break.